All right, so good afternoon. Hopefully everybody is having a great reInvent. It's been a little wild, right? So my name is Nicholas Rosamatos. I work for Red Hat in the CCSP group, which is the Certified Cloud Service Provider group. And I work specifically with emerging technologies, both within the cloud, on-premise, and hybrid. So today we're talking a little bit about OpenShift, then we're going to bring out one of our customers, CA, and they're going to talk about how they're using OpenShift currently. And then we're going to actually do a full demonstration of OpenShift end-to-end. So a little bit about Red Hat and AWS. I'm sure most everybody here is familiar with Red Hat and AWS, but just in case, obviously. So Red Hat, we've been trusted in the industry for over 9 years currently. We're the #1 leading provider of commercial IT products and solutions based on open source software at this time. We've been trusted in industries for over 9 years working in collaboration with AWS. We currently have almost 9,000 employees and we're continuing to grow. And one thing that's really interesting is 99.9% of our enterprise customers trust us with their environments and we help them reach 99.9% uptime. And then Amazon Web Services, they've had 10 years in cloud leadership. Currently 35 availability zones. I believe that's actually more now. And spanning 13 geographic regions, which I also believe is more now. And they've made over 700 service improvements since 2015. So Red Hat and AWS have kind of collaborated in a lot of ways to actually bridge the gap when it comes to hybrid-based clouds, right? So OpenShift, the initial design of it, and as it continues to grow, we tried to make it agnostic from the environment, right? So cloud agnostic, infrastructure agnostic. So essentially wherever you can actually run Red Hat Enterprise Linux in a supported design or certified, you could actually do it. So AWS Cloud helps you leverage that, and you can use OpenShift in either or. So Red Hat OpenShift on AWS. So we've noticed over time, right, transformation of applications and infrastructure and process, right? So we move from monolithic large applications to kind of more of a n-tier fault domain type of environment, virtual machines, things along those lines. And then obviously we're moving towards microservices. What we've realized over the years is the fact that virtual machines sometimes sit idle, right? They are only used for a certain period of time, and the rest of the time they're just consuming resources, money, time, cooling, et cetera. And then development process. We moved from waterfall to agile, and now everybody is talking about DevOps, right? CI, CD, continuous integration, continuous deployment. And then application infrastructure. So we moved from data center to hosted, whether that's within your own internal organization or data center and cloud. Now we're seeing true cloud, right? Your own private data center cloud, public cloud, multiple clouds, hybrid-based approaches, things along those lines, right? And the main design of OpenShift was that containers to be able to span all of this and tie all of these individual components together, right? So these changes are driving a lot of the conversations that Red Hat and AWS is having with customers. So OpenShift is Red Hat's answer for container applications. One of the first things that we wanted to make sure when we were designing OpenShift was that it was enterprise grade. And what I mean by enterprise grade is the ability to run production-based traffic, right? Not just DevOps, but we wanted it to be able to satisfy requirements for internal and external customers. We also wanted it to be able to run traditional, or as sometimes people refer to them as legacy applications, and cloud-native applications. So stateful, stateless, persistent storage, things along those lines. And we wanted it to be able to have an integrated hybrid cloud platform, specifically because development and deployment. And it needed to be portable, so designed to develop, build, manage container-based applications. These are some of the main fundamentals that we were looking at. And we'll do a presentation on this, but we wanted to make it really simple for developers and operations to turn source code into running applications, right? We call this source to image. And we wanted to simplify that entire process using things like pulling from Git and Subversion and Jenkins and such, tying that directly into OpenShift. And then multi-language. And when I say multi-language, I don't mean, Spanish and French and so on and so forth. I mean tools that your developers use today, the languages that they use today, they should be able to take that and run it in that infrastructure. They shouldn't have to constantly relearn new tools and new APIs, new programming languages, and things along those lines. It makes no sense. It just slows down the development process. So, our container adoption. When it comes to containers, as the largest open source company in the world, we wanted to make sure that the ecosystem wasn't fragmented, right? And we wanted to preserve the ecosystem by bringing it all together. And there's 4 standards or 4 pillars that we really wanted to focus on. The first actually started is something that we've been driving for a long time, and it pushed into Linux containers. So that would be things like SE Linux, correct? One of the other things is the ability to scale. Integration, simplified management, and then certification. You don't want to run a production platform that's not certified, right? Whether that's compliancy-based or on an infrastructure that's not certified. So benefits for developers. How does OpenShift empower developers, right? So access to a broad selection of application components, deploying application environments on demand. Provides a lot of different benefits, right? The ability to leverage your choice of interface and integrate with existing tools. So maybe they want to use, Git and Subversion for source code management. Maybe they want to, use CI/CD for continuous integration and continuous deployment. And enabling collaboration specifically between different teams. So different teams, users, objects, things along those lines, and automating those builds for themselves. And then IT operations. So it's not just all about developers, right? Containers simplify the development process, but it also needs to simplify IT operations. Otherwise, really, it's only one-sided benefit. So we want the ability to have the APIs and manage replication and things along those lines to deploy secure enterprise container-based applications. We want to also enable application developers while enabling operational efficiency, right? Infrastructure utilization. Things don't need to sit there idle, right? You should be able to consume all of those resources. You shouldn't have to necessarily worry about, does my data center have enough space? Do I have enough compute available? Do I have enough storage available? These VMs are sitting there, they're idle all the time. They're just consuming resources. So we also wanted to develop advanced scheduling and automated placement. So leveraging as much automation as we possibly could. Using also declarative management for applications. And then manage users and teams and integrate with enterprise-based authentication systems, right? OAuth, LDAP, things like that. So why would you use OpenShift over just rolling your own container platform? How many people here are running containers currently? Anyone? Who's running them in production? Okay. Did you roll your own, or did you find a solution that you ended up implementing? Okay. It's yes, okay. So, the thing when you start taking different components, right? Let's say you wanted to go and you take Docker and you take Swarm and you take all these other components and you start stringing them together and you take the hypervisor and the nodes and the master and you start throwing all these things together. And you're using maybe an external registry or something along those lines. Do you know what's inside your container? Where you're pulling it from? Do you trust it? I mean, someone might have built it, throw it on Git, you pull it down, you make configuration changes to it, you deploy it. I mean, that's not a great idea, right? How when will applications and libraries be updated, right? Are you going to pull that down? Are you going to maintain it yourself? Will it work from host to host? So different environments, right? Maybe you're running OpenShift or you're running some other application within your own data center, and then you're running ECS, right? You can use the same tools, can't use the same APIs. And then can I use the same solution on-premise and in the cloud, which ties into that as well. So a Red Hat certified platform of OpenShift allows trusted source for the hosts and containers, right? Red Hat Enterprise Linux for the host and the nodes. And then obviously we do certification on the containers as well. So we actually have our own private repo and registry that we do our own scanning and testing against and validation against. So we can trust the content that's inside the container with security fixes, being able to be part of the enterprise application lifecycle. And then obviously portability across hosts, as I mentioned. As long as RHEL could run there, OpenShift can run there. So certified container images, certified middleware, the certified Red Hat container registry. We have a container development kit, and then obviously certification as a service. So we leverage a lot of different things for our customers. So OpenShift compared to some other platforms, right? We wanted to have a better developer experience, a bigger selection of fully supported services, right? Continuous growth, continuous things being rolled out, new solutions, new integrations, more powerful standard-based orchestration engine, right? Declarative management, making things simple, more secure, more standard-based container model, right? So that OpenShift ships with its own registry. You don't have to use an external registry unless you choose to do so, and that's completely up to you. Some people do, some people don't. And then obviously the OS itself, right? So whatever you're running, you want to make sure that it's secured, and obviously Red Hat's completely open source. You have access to all of that individual code. You can see what's going on when it comes to the community, and we actually have one of the largest communities that's out there. So we chose Docker images for the application services. We chose Kubernetes for the orchestration and the management layer. We went Docker with the Linux containers. And then obviously RHEL 7 or Atomic Host, which is another version of RHEL. It's more of a stripped down bare bones image. So one thing we also offer, not just that you could roll your own OpenShift environment within AWS. You could choose to do that if you want. We have things like Cloud Access where you could take your application or subscriptions and convert those over and import them. But we also have what we call OpenShift Dedicated. And that actually is a platform that we manage for the customer. So the customer can only, they spend their time focusing on deploying and scale of containerized applications and services, right? They don't have to worry about the infrastructure components. They get premium support from Red Hat. So they can open up a ticket, they can get design, they get architecture documents, they can access the portal, they can participate in the community. We have an upstream project which is called OpenShift Origin. They can, run things with Origin. They can contribute to Origin. And you get your dedicated entire OpenShift cluster. So it's actually dedicated resources that are actually built directly from you or for you. That's multi-tenant for yourself, right, for your different verticals or application groups. But it is your environment. It's not a shared environment. And then we do the setup, maintenance, and the cluster dedicated to your organization. And VPN connectivity into your environment, if that's what you choose to do so. Obviously, most people do. And it's hosted in AWS EC2 in regions of your choice. So you might want to span multiple different regions. Maybe you go through a customer acquisition, they're in a different country, their hardware is old, maybe you want to re-architect some of their applications, you don't want to build a whole new data center because all of their stuff is coming end of life and deprecated. So you start moving to a different design. And this gives you a basic idea of what it allows you to focus on and what Red Hat covers, right? So we cover everything from the container orchestration cluster services all the way down to the physical infrastructure component, right? And then that allows you to focus on middleware, self-service, containerization, automation, things like that. So benefits of Red Hat OpenShift on AWS. We provide a complete enterprise class, scalable computing environment, and it's simple. That's really it. We give your organization access to a secure and easy to manage platform. So it's changing as your business needs. We also have the power and flexibility of your own OpenShift container platform, which is clustered and built by Red Hat Engineering Operations and Support. And then we host, obviously, with OpenShift Dedicated on AWS. So it's cost-effective, secure, reliable. You get all the benefits of Amazon EC2. And then, as I mentioned earlier, and we could provide more information on this, there's some links and then, but your Red Hat subscription provides access to technical experts, support services, things along those lines. But also, Cloud Access allows you to take your subscription and move it into the cloud. You don't have to buy new subscriptions. You could actually take your subscriptions and migrate them over. And then when you use Red Hat Linux on EC2, you're actually only paying for what you use for. And then pre-existing subscriptions, as I mentioned, Cloud Access and flexibility to run Red Hat's entire portfolio of software operating. So full stack JBoss on OpenShift. We actually support .NET and Microsoft SQL too. So the architecture, what does it look like? So as I mentioned earlier, at the bottom of the stack, you have your own physical or virtual infrastructure. When we developed OpenShift, we wanted it to be infrastructure agnostic, right? You could run it anywhere. And then you have your nodes, right? And your nodes are basically dumb. They have no intelligence whatsoever. There's two primary components when it comes to running OpenShift. Obviously, the first is the node, and they have no intelligence whatsoever. And then you have your pods, a container image or container run within a pod, and they have all of the dependencies and integration and components all rolled into one. So pods are orchestrated using OpenShift. Containers which live within the pods, traditionally separated, such as like with fault domains in a sense, they get placed wherever they need to get placed. And obviously, you don't want everything running on one individual host, so it separates things out, right? So 3 pods across 3 separate individual hosts for high availability, load balancing, and things along those lines. So this infrastructure is not any different than currently probably how we're deploying our own infrastructure today, right? You don't put everything on a single individual host and then that host goes down and suddenly everything's on fire. So masters are the actual control plane. They're the intelligence behind everything, right? And the Kubernetes API server, it actually validates and does the configuration for the data for the pods, the services, replication controllers. It also synchronizes information and actually does the service configurations. Then you have the data store, which is the etcd database, which is a distributed key value data store. It stores the persistent master state while the other components watch etcd to make sure that changes bring themselves in line, right? So when things get out of line, and I'll show you a little bit about that, it actually brings things back in line, so it understands failures and things along those lines. And typically, it's actually deployed in a sense where it's highly available, so you don't just have one master. You could, but you shouldn't. And then your scheduler is actually one of the most important things, right? Determines where your Docker images are going to be deployed. How do you scale? What's the orchestration look like in your production environment? Pulls the Docker images from the registry. Deploys the pods wherever they need to go. And the registry tightly integrates and controls where images are being stored, who has access to those images, lifecycle, check-ins, check-outs, things along those lines. So when you imagine deploying a container or a pod, it would pull the Docker image directly from the registry, depending on the characteristics that you specify, and based on utilization, or maybe you have some other specifications that you want, like such as a placement policy, puts it where it needs to be. So in this example, we want a front-end application, right? Let's say we're using Tomcat, we have MongoDB and whatever else you want to consider it to be. And the big thing to know is none of these pods on the node can actually talk to one another, right? So they're separated, they're segmented. And maybe you want to run very large nodes, right? So maybe it's very memory-intensive based applications, large containers. Those placement policies that you could specify can basically determine, well, what node should this be running on? And then the service connect application components, right? So the important thing to know is, as I mentioned, containers are not visible to the outside world, right? They don't even know each other exist. So we expose the containers using the Kubernetes service layer. And Kubernetes service layer is responsible for the routing of traffic. It allows you to configure specific containers to accept or deny traffic from other containers. It allows essentially the routing individually between the nodes. So it's essentially service abstraction, right? And then health and scaling, right? That's one of the big things of why everybody's moving to microservices, right? So scaling functionality, other system components become unhealthy. You have failures, probes that make sure that things are healthy, and if something's not healthy, then it actually pulls that stuff out. So what if there's an unhealthy pod, right? Or an unhealthy node? Things fail. That's just the way it is in life, right? So the master remediates the pod failure. It says, hey, this node is down. Wow, I'm not within the way that I'm supposed to be designed. What do I do? Redistributes the applications, right? Another thing to note that we have on here is persistent storage. So as I mentioned earlier, we wanted to make sure that no applications get left behind, right? Legacy applications that are moving to containerization need storage. It's just the way it is. So We leverage the Kubernetes API for it, and you actually have the ability to have persistent storage. So if a container fails or a pod fails on an individual node or host, it could be restarted, it can mount that volume, it can continue moving on. And then the routing layer, right? So this is your load balancing. It's a plugin to assume and bind host to ports within an individual node, right? So it provides the internal to external mapping, and it assumes that the networking is configured so that it can actually access the pods in the cluster. So your developers, how do they access all of this through the master, right? They could use source control management, Git. They could use CI/CD. Your operations can use existing tool sets. Nothing any special. So I'll talk a little bit about that right here. So they can use developer CI, administrator CLI, your web console, and then through REST APIs if they choose to do so, right? And you have your users, your groups, or authentication. That's all done through OpenShift. The projects are within OpenShift, and then Kubernetes leverages the namespaces. So the architecture application for OpenShift, source to image, build configuration, integrated Docker registry, image stream, which is tied to source to image, deployment configurations. The other components we leverage from the Kubernetes project, right? Persistent volume pods, things along those lines, routes, and software-defined networking. So I'd like to introduce Ganesh from CA to come up and tell you a little bit more about how they're using OpenShift.
Hi, everyone. My name is Ganesh Janakiraman. I work for CA Technologies in SaaS operations and delivery. CA is one of the leading software providers. We have a rich portfolio of products. CA also has, sorry. Okay, sorry about that. CA also has a few market-leading SaaS solutions in the project and portfolio management, agile, online payment security, performance testing, API gateway, identity and security, to name a few. These are 24/7 by 365 mission-critical applications accessed by customers globally. So we have a global footprint in terms of our presence in North America, LATAM, APJ, EMEA, for redundancy, and we see these data residency constraints coming a lot these days. Security is paramount. We are in a strict regime of audit, compliance, and security that helps us in getting all these compliance certifications. We had a very interesting election season. Some of you may have accessed this app, CNN Politics, which is built with CA. The mobile analytics for this app, we call the application experience and analytics. That's one of the SaaS solutions that we offer. And this is one of the solutions which runs on the OpenShift platform as well. So before I go too deep into how we use OpenShift today, I want to talk, I just want to take a few minutes to talk about where we started with this a few years back and what was the problem that we wanted to solve. Okay, so let's take an application with a backend web service. It could be a small Tomcat app serving static HTML pages, or a Jetty with Node.js, or it doesn't matter. Let's take a small app. Okay, how can we actually deploy this service? So let's say we have one instance of the service can handle 100 users and requires just one CPU core. And let's say we just have 100 users. We could simply run this service on a physical box with just one core. There are no issues. But in SaaS, when an application is out there in the open, what stops it from 100,000 users accessing that, right? So we have cases like Black Friday, Cyber Monday. So we are familiar with the issues with scale, right? So with 100,000 users, taking the analogy a little further, we need 1,000 instances of this with 1,000 cores. And how can we deploy an app with 1,000 Tomcats, right? So it's a fairly complex problem, and the solutions that we looked at had to meet a certain set of criteria. Let me quickly walk through like what these criteria are. The first one, of course, is cost. I mean, SaaS, for any SaaS to be productive, you need to have scale, right? And the cost efficiency is really important in terms of the efficient hardware, software, and the operations labor, which we call it the OpEx. So that's a critical factor, right? The second one is isolation. When I talk of isolation, I mean resource isolation. We cannot have, when we have a plethora of services running in a platform, we cannot have one renegade service kind of taking away all the resources and bringing down the entire platform, right? So isolation is a key criteria. The last one is flexibility. We talked about the Black Friday, Cyber Monday example. What if you need to scale up, scale out, add, shrink services dynamically, right? So we should have the ability to be flexible, to be able to scale the services easily, okay? So how do we approach these issues? So one way to look at it is having a set of huge, large servers which can run all these services. But at the face of it, we may have just a few servers to operate, but everything else is bad about this idea. Be it cost, be it isolation, be it flexibility, this is a non-starter, right? So what else could we do? We could instead of going the humongous servers, we could have a horde of these tiny servers, which is a different option. You definitely achieve isolation with this. You have a well-isolated system, but in terms of cost and flexibility, it's a very bad idea, right? So enter virtualization. So virtualization has solved this problem in some form. I think in the industry for the last 10 plus years, I think quite a few of us have used virtualization in a very successful way. But does virtualization solve all the problems, right? So if even given a physical bare metal server, I'm able to virtualize and make smaller VMs of it. The isolation is good. In terms of CapEx, yes, it's a good solution. But I still need to maintain 1,000 VMs, right? And purely from an operations perspective, I still end up maintaining 1,000 VMs, right? So is there a different way to actually solve this problem? So here comes containers. So I just saw quite a few hands going up here in terms of people who are using containers today. I don't need to preach to the choir, but in terms of containers, I think though this technology is fairly old, it has been here for a few years now, we see a rapid adoption over the last few years. There are valid reasons for that. So with containers, in terms of the cost, we do achieve CapEx, OpEx is okay, good. The isolation, initially there were concerns in terms of security, but I think we are at a point where there's a lot of production workload which actually runs on containers today, right? So we still have an issue. So even if I move to this approach, we need to have a way to handle containers. I mean, who handles the life cycle of this container? I mean, what do I need to do to scale up, to manage and to shut down the container, right? So we still have that particular problem. So that's where I think the OpenShift solution kind of fitted the bill in terms of we not only have the right platform for containers to run, we also have the orchestration which is required for this platform to run successfully, right? So we at CA, we've been using OpenShift since 2012, one of the initial versions of OpenShift. And with OpenShift 3, there's been a tectonic shift in terms of the architecture. OpenShift 3 now supports Docker and Kubernetes, as Nick explained. So one thing with Docker is Docker has kind of pushed the adoption of containers to a point where now we think of Docker as a de facto container technology, right? So, and Kubernetes is a proven container orchestration platform. And Red Hat, on top of it, provides all the administration in terms of the web console, the CLI, the role-based access, service templates, security, and much more, right? And we at CA, we use OpenShift in our own colo data centers, which are VMware-based, and quite a lot with Amazon Web Services. So I just walk through a few of the features that we use today with OpenShift. We do have multi-tenant apps, but what I mean by multi-tenancy with projects here is within the OpenShift platform, there is a level of isolation that these projects provide, where I can assign users to particular projects, where I can have resource assignments, constraints that I can put around projects. So there are different levels of isolation which we achieve with projects, right? So we also use auto scaling quite a bit. Auto scaling with CPUs. I think Nick touched upon it. So we have Hawkiller and Heapster kind of comes in with OpenShift. So when a pod reaches a certain threshold of the CPU, the metrics are compared, and once it crosses the threshold, it can scale out based on the number of replicas that is set as a part of the configuration, right? So we also have different deployment strategies which we use, rolling, A/B, just name a few. And as I mentioned, we do have protections in place. We do have, in terms of the resource allocation caps, both at the container pod level as well as at the project level, which helps us manage our workloads quite efficiently. And we do actively use the integrated Docker registry that comes with the OpenShift 3.3 now. And source to image is a very exciting feature that we use. Without further ado, I think I would introduce Jason to demonstrate how OpenShift handles S2I. Thank you.
Okay, my name is Jason Dobies. I'm an engineer at Red Hat, and I get the honor of doing the always fun conference live demo. So you see now we're looking at just the intro or the basic landing page for the user interface. I have one project deployed, so it's got a normal multi-tenancy user model, so I'm logged in as myself. I have a single project deployed. As you can guess by the name, that's in case everything falls apart. I hopefully have something to fall back on. We're going to start with a quick demo. So I just want to create a new project. A new project is going to be a collection of applications, various things I need to support my full-blown running service. We'll come back and we're going to do another example for this browse catalog. We're going to start with something simple, deploying an image. And again, there are a lot of different ways we can do this, but I want to address just your basic run-of-the-mill. I have an image in Docker Hub. It's named under my account. And all I want to do is deploy that. Now, this may or may not be your typical model, but for a demo, it makes a great example because if you were to take origin install and get an install running locally, you can very easily start deploying Docker images you have created. There's no difference in writing an image specifically for OpenShift. Now, you'll see here this warning about must being run as the root user. I could go on and on about this issue. What it comes down to is that where container development and container paradigms are still kind of evolving, and we're trying to get people realizing that running as a root, not the best idea for a container. Depending on your configuration, it may or may not even launch within OpenShift. For my purposes, it will, but I wanted to, again, highlight that. So I drop back to our landing page, and you can see some stuff is already going on. Now, this one executed pretty quick because, admittedly, I have pre-downloaded the container, the image. But as you can imagine, all that really happened there was downloading it from Docker Hub. It's, again, conference Wi-Fi. You're a little bit nervous about it. But what are we looking at? So we're saying there's a Python web service out there now. I have one pod. A pod is the Kubernetes term for effectively a container plus some metadata, and that's it. It's deployed. It has taken the image from Docker Hub. It's created a container somewhere. I should point out it's a little difficult to see the URL, but this is an instance running in AWS. And this container is now deployed to one of my nodes that I have configured with OpenShift. So how do we get to it? How do we actually access the service? Over here on the right, you'll see a button for creating a route. A route is your ingress into an application. Now, we make it so you have to do a specific extra steps, and there are ways to automate that. But then explicitly saying, I want this to be publicly visible. I'm going to autofill this in to make life a bit easier. We'll do Python demo. I don't have any kind of full-blown DNS server set up, so I'm simply using a zip.io address. There's a lot of other options that I can mess with there. What it's effectively saying is, I want you to expose this service at this particular host name. Within that, I could have configured secure communications. I could have changed the port that it maps to within the container. But for our purposes, this was plenty. And no surprise, I did a hello world application because that's what you do. So that was as basic as they come. I do want to show one twist on this. So this was a canned image that, yes, I wrote, but you can understand that this would be an image that I don't have the code access to. How do you typically interact with them? Environment variables tend to be your avenue for, I don't want to rebuild the image, I don't want to have to recompile anything, but this is how I inject my own data or my own configuration into the running container. So in this case, when I wrote this application, I simply look for an environment variable named text, and that's what I'm going to display on the screen. So I saved that, and I'm quickly jumping over to the overview screen. You could see Docker has already kicked things into action. It didn't show it. I didn't get there fast enough. It scaled down the existing pod and stood up a new one. These containers become immutable, that it's not going to make that update directly into it. Either a code change to as simple as an environment variable change is going to cause an entirely new pod to get stood up. Now when we go to that application, we refresh it, we get our new text, goodbye world. I saw this once in a demo. It's kind of morbid, but it actually does end up making for a good example or a good kind of parallel to your typical hello world. So that's if we wanted to take an existing Docker image and get it deployed in OpenShift. But that's not the real fun part about working in OpenShift. So let's do another one. We'll call it the PHP database demo. This time we're going to start at the catalog we have within OpenShift. Now, when you install it, it gives you a set of images that you may want to build from. They range from your languages that you can build off of, and I'm going to come back to this for a PHP example, all the way down to something more concrete, like a database. And when I stand this up, there will be a database container running, and I'll have configured it with storage or left it ephemeral. For now, we're going to start with the PHP builder. And I do say builder, that's a very specific term that we use. A builder image contains the basis for what you would need to build new code for this particular language. So right now, I'm over here in GitHub. I have my PHP demo code, simple file, and then the image that you're going to see. I'm going to name my application. I'm going to give it the URL to my GitHub account. It's not going to be any URL for cloning it or anything like that. Just simply, here's where it is in GitHub. We're going to create a route, and again, I'm going to explicitly type in something that I know I can get to. If I were running this purely locally, it will generate a zip.io address for me, so I'm very happy I remember to do this step because often I just kind of click through and keep going for development purposes. So I've given it a name. I've given it the location of my GitHub repository. Now this one's going to take a little bit longer. It's a good time for me to show you around the UI a little bit more. Right now, it's doing a build, and I can actually click into that and give us some information. I'm hoping you can read that. It's talking about pushing layers. These are Docker constructs. It's starting with that PHP base image, which really is just your basic Docker image. It has some PHP utilities installed in it. It has some additional scripts on there for understanding how to build a PHP application and copy it to the right directory. You need to know a little bit about what this does. You'll notice I just specified the GitHub repository, and it just had a PHP file. If I really needed to care, I could dig into the builder image and figure out, oh, it puts it in /ops/approot, and here's how it starts it, and so on and so forth. Again, we're using the PHP one. There are ones for Python. There are ones for Ruby. And then you can always write your own builder image. I wrote a series of documentation using Sphinx, if anybody's ever heard of that. Very similar to AsciiDoc, which I know a lot of my coworkers use as well. Same type of premise. There's a builder image that will take a repository that has a Sphinx build system in, or I'm sorry, Sphinx files in it, and it will build it and put everything in the right location, and then poof, that all appears. So we see at the end here, push successful. I hop back. We see my pod's created. The dark blue ring means it's finished. You saw probably earlier, you noticed it was spinning up and it was light blue, and you can kind of see it graphically move around. We selected to create a route for it, which I may have either mistyped or I clicked on too quickly. So we'll give it a second because it may still be looking for the database. So what this app is going to do for us, PHP demo, that's the right address. It's embarrassing, so we're going to end up coming back to that. This would bring up a site. Now, it's written as a cloud-native application. So what it's going to do is, when it does start up, it's going to look for a database. It's not going to find one, so it's going to fail fairly gracefully, or in this case, it's going to fail entirely. But I will still go through the process of actually adding a database to it. So let's imagine the site's running. We have our code out there. We have an image built. That's great, but applications are bigger than just a simple PHP site. You are going to have your message queues. You're going to have your databases and so on. So we'll go up here to Add to Project. We'll browse down to what I mentioned earlier about the MySQL. Here we'll type in some information. So I can have it generate a lot of this, but I know I need to connect my site directly to it. So we'll fill out some basics here. It's going to use a user. It's going to have a password, all demo. This way I can configure my site to actually use it. When I hit create, we're going to hop back. There we go. So this was the site that you guys were originally supposed to see. We're going to pretend that server not found in here. I'm going to network hiccup. So while the database is standing up, you'll notice it does say database not available there. And this is what I was mentioning earlier, that the new paradigm of, hey, I'm deploying a microservice. You don't exactly know how everything's going to start up. So right now we have our PHP site. It came from simply a GitHub repository. I pointed it at a PHP builder image, and it went and it created the container. It pushed it out there. And when I set up the route, it actually configured it to route to it. But again, database not available. We haven't finished standing it up. We haven't finished wiring them together. Now, I use an ephemeral database for this demo for simplicity purposes. If I had used the persistent storage version, it's a little bit more complicated of a demo where I would have requested from the cluster, hey, I'm going to need a persistent storage volume. It's going to be this size, and so on and so forth. So first thing I'm going to do is I'm going to group this with the MySQL service. You'll see they both now appear side by side. But again, how does my PHP site know where that database is? How does it know how to connect to it? We're going to do the same thing we did earlier, except we're going to go through the environment variables, and we're going to set them specifically for MySQL. We're going to use the values I specified earlier. I'm going to hit save, and as we hop back, again, it's an environment variable change. Don't have to change the code, don't have to change the image. Still going to deploy a new pod for us. If we go over to the deployed application, you'll see this time it found a database. Hey, the database is available. Since it's my first time finding it, we're going to run through an initialization. And all this is going to do is every time I refresh it, it's going to capture some information about the visitor who came. Container IP, this is the IP of the pod that's actually running. So we have a database running. We have the PHP script set up to it. I should also point out there's no specific route to the database. It was easier to see before I moved it in the group. We don't want to expose that to the public world. We simply want other containers running in our application to have access to that. let's hop over. So let's say, I'm going to talk about things from a developer standpoint now. I have a Git checkout of that repository. If I'm making changes to it, I'm going to want to go through GitHub. So we'll do something very simple for the purposes of our demo. While that's pushing, if I come back and refresh it, you'll notice nothing has changed. And that shouldn't really come as a surprise. I've pushed things out to Git, but I've never told it, hey, there's some new code out there. I need you to rebuild things. So if we go back into OpenShift, we go into our build section, you'll see that we have our PHP site. Last build was number 1. We've only done that once. And I'm going to kick off a new one. You can see down here in the middle, it started running a build. It should progress significantly faster because the vast majority of the layers have been created. So that earlier screen where we saw pushing 1 of 9, 2 of 9, most of those basic ones haven't changed. It doesn't need to rebuild those. It's simply rebuilding things at the lowest code level. So you notice that finished significantly quicker. We hop back in and refresh it, and we now have our AWS logo up there. Now I'm running a bit shorter on time than I would have liked to, so let's skip to the scaling portion of the demo. Oh, no, let me talk about at least what I would have showed. You can trigger a GitHub hook where I can go into this application, I catch a URL, and then I paste that into GitHub. And every time GitHub's going to detect a new push into it, it'll send a message over to OpenShift. So that whole process where I had to go in and say start build goes away. OpenShift gets the push request and understands, hey, there's something new in my repository. I need to do a new build. And it does exactly what we just saw. It creates the new image. It scales down the pod. It scales up the new one. Great for CI integrations. Great for production pushes. You don't even have to take that extra step. It's an extremely developer-friendly environment that I'm simply working in the confines of Git, and it's using a lot of automation to pass things through. So let's say I want to scale this up to 2 pods. Done. I now have 2 containers running out there. They're automatically load balanced by OpenShift. There are deeper examples with a full-blown A/B type of setup, but for now we'll simply say I need a little more bandwidth. So I'm going to have 2 containers running, same site, both pointing to the same database, and OpenShift is going to automatically load balance for us. So I'll hit refresh a few times here, and this is nice because it made my life a little bit simpler for the demo. Notice the IP has changed. It's pointing at the newly built pod, and it's keeping the sticky session. I can go to a private browser, and I'll hit refresh a few times there. You'll notice the IP has changed. What this is pointing out is that the new browser, it's considered a new session, it has pointed at the second container. And there are different ways to tweak that algorithm, but for now it's just simply round robin between the 2 of them. New users come in and they'll sit there waffling between the 2 IP addresses we have up there. So again, I did mention the term an A/B setup earlier. You could use this for rolling out new versions that we want to put some new changes in. We're going to say, I'd like 70% of my traffic to go to the existing service, and let's kick 30% over to the newly deployed image. And want to see how it functions, see what comes up. So that's the basics. You can see a lot more information. We have a booth over in the central area. I will hang around for a bit after that if you'd like some more questions. But again, to reiterate the highlights, the big thing I wanted to show is the source to image. Extremely developer friendly, that I simply give it a Git repository and it does everything else it needs for me. I never wrote a Docker file in there. It just took that from the PHP builder image. I never had to write any specific hooks in that say, hey, I'm running as a container, hey, I'm running in OpenShift. Figured all of that out on its own and automatically built it for us. So with that, I'm going to hand it back to Nick to finish things up. So thank you, everyone.
So one thing that I actually wanted to talk about is we actually have a POC program that we just recently worked with Amazon on. So we built a Red Hat Quick Start in collaboration with Red Hat and AWS with our OpenShift team The quick starts are automated, so you can actually go. They're built on CloudFormation templates. You literally click it, provide some details within your AWS account, it stands up a cluster. And if you want, you have the ability to request $2,000 worth of credit from AWS to deploy Red Hat OpenShift on AWS as a proof of concept. So we'll support you with it, and we're interested in anybody who wants to take a look at it. And Amazon is pushing this with us as well. So obviously, you could go to aws.amazon.com, partners Red Hat, to request the details, and we would love for people to participate. So not a lot of people are doing this right now, but we're actually really interested, and Amazon's really pushing us to do it as well. So, and then with that being said, obviously we have the normal resource page. We'll hand this out with the presentations when they're shared, and then we'll open up for Q&A. If there is any Q&A. I know there's a lot to cover. Okay. Hope you guys have a good rest of the conference.